So today we're talking about division of fractions. This is probably my favorite math. Well, okay, actually, I don't know if I can call it my favorite. It's close to my favorite. I also like ratios is my most favorite unit. But if I were to pick one concept, it would be division of fractions. Are you guys calling in people from the outside? Okay, thank you. I forgot to do that. You guys are invited back in for the lesson. All right. Okay. So let's talk about division of fractions. Here we go. You don't have to learn how to do a new thing because division of fractions, we're going to manipulate it so that all we're doing is multiplying in the end. So first thing I want you guys to write down, division is the inverse of multiplication. What does inverse mean? Dorothy? The opposite. Good. It's the opposite of multiplication. Can anybody else think of another inverse relationship in math that we talk about? Rajveer? Addition and subtraction. Good job. So it's kind of similar, isn't it? All right. So division is the inverse of multiplication. Why isn't my thing working here? Oh, here we go. All right. We have a dozen cookies to hand out at a party for hungry sixth graders. Hopefully they're not too hungry because each sixth grader is only going to get, oh, I'm just kidding. Each person gets two cookies. How many people at the party would get cookies? I have a dozen cookies to hand out at a party for hungry sixth graders, and I'm going to give each person 2 cookies. How many people would get cookies at that party? Cecilia? Yes, good job. I can't find, do you guys see my pen anywhere? It's on the other side. Thank you. Okay, 6 is right. What did you do there in your head? Yeah, you divided 12 by 2, right? And you know, so that I can feed 6 sixth graders. They're going to be 81 sixth graders that are really unhappy, but 6 will be very happy. Tommy? That's a 6. Here, I'll take my tablet off so I can write a little bit better. And you won't have to ask me that question, hopefully. All right, next question that I have for you guys. Now, I have 12 cookies. Oh, nope, I'm sorry. I thought I had the other one up there. Here's my bar model. Let's go to the next question. All right, so 6 students get 2 cookies each. All right, next slide. Now we're throwing a party for a group of supermodels, and they're only going to eat a half a cookie each. Okay, I still have 12 cookies. How many supermodels get a cookie? Excuse me, how many supermodels get half of a cookie? If I start with 12 cookies. It's a term from the 90s. I don't even think that's a thing anymore. Jace? 24 supermodels get a half a cookie each. All right. So we can make 24 people really happy. Jace, did you just divide in your head right there? Did you just divide in your head? You kind of did, though. You just didn't know that you did it. You did divide. What you did was we were asking the question, how many half cookies are in our bunch of 12 cookies, right? And you told me 24, and you gave me the right answer. And it makes sense if you visualize it, right? If you cut all of those cookies in half in your brain and you hand them all out, you're going to have 24 halves, right? Our division question is, how many halves could we get out of 12? And we end up with 24. Is it weird though that we have a quotient? Remember what our parts of a division problem are? That's our quotient, right? We have a quotient that's bigger than our dividends. How is that possible? Existential questions, friends. Piper? Yeah, it's because I divided a whole number by a fraction. Macy, go ahead.
So also 12 or 1, 2,
Ooh, you just noticed the pattern. That's what I'm going to teach you today. Yes, nice job. So Macy, notice if I flip the 1/2 to 2, It's 12 times 2 is the answer, right?
But what if you
Okay.
have, like, some,
What if I, no, go ahead. What if I have what?
if you, but like, that couldn't really work all the time. 'cause
Really?
What if you have a numerator that's not one?
Okay, let's just see. What if I have a numerator that's not 1? What do you mean?
Like, this is 1/2, so all you have to do is, multiply 12 by 2.
So so like, let's say I have the question, like, if I want, okay, so you're saying if my question was, what if I want to give each person 2/3 of a cookie? Would that be a good representation of the question you're trying to ask?
Yeah.
How many people could I feed with 12 cookies? Well, we could draw it. Let's see. Let's draw each of these. I mean, you guys don't need to. I'll just draw them really quick. Okay, I'm gonna separate all my cookies into thirds, right? How many groups of 2/3 then can I get out of 12 cookies? Let me hide these meeting controls. Right there. There we go. So Michael, why don't you answer that question for us? How many groups of 2/3 can I get out of that?
Well,
I don't know. No, I think I can get more than 12
wait,
because it would be 12 wholes that I could get out of that. So let's see, I've got, let me just mark off 2 on each cookie. Okay, we know we've got at least 12, right? And then from each cookie, let me just mark these off. From each, hold on, nope, it's not. From each cookie, okay, I would have 12 2/3, right?
Yeah.
And then each cookie would yield me an additional 1/3 of the cookie, right? Plus 12 1/3. Do you agree? Okay, so let's see how much that would be. That would be,
Oh. I see.
that would be more than 24, wouldn't it? Yeah, it'd be like 3 times 12, which is 36 plus, that'd be 38 thirds
30?
plus 37 thirds. That doesn't, I don't think I did that right.
That would be,
No, that's not gonna, that's just gonna give me 12 cookies. I'm not illustrating this correctly. I apologize. I would have,
30.
if I would have 6 2/3 left. That would give me 18 portions of 2/3. Does that make sense?
Oh,
Because I have 2/3, we're asking really hard questions.
I
here,
kept
Mrs.
thinking,
Allen.
the individual.
Yeah, this is our favorite math lesson.
I was
Okay.
thinking the individual thirds, not the 2/3.
Right, and so was I, and that's why I wrote it down wrong, because I was having a hard time to do that. But if we look at just our model, I've got 12 groups of 2/3. Do you all agree, class? Okay, everybody restart. Show me your star font, guys. It's really important you understand this conceptually. Because Michael brought up a good point that he thinks it only, like our thing is only gonna work when we have a certain numerator. So we have 12 groups of 2/3, then we'd have another 6 groups of 2/3, right? Because each cookie would yield 1 more third. So that would give us 18 groups of 2/3. We could feed like 18 supermodels. Okay, and Macy noticed that we could multiply 12 times 2 to get 24. So let's see if we can do something here with the 2/3 to get our answer. And I'm hoping I visualized that correctly. Let's see if it works to multiply 12 times the reciprocal. Let's see what we get. Ooh, what do we get, Michael?
18.
We got 18, didn't we? Oh, snap. It actually, it works every time. Okay, yeah. So good job with our algorithm. So that's what we're going to get to in just a minute. We're going to talk about the algorithm for actually dividing by fractions. Okay, so here's our method. All right, we've got a problem here. Jacob, Miguel, Emily, and Michonne shared 2/3 of a pizza. What fraction of the pizza did each of them get? First of all, how many friends do I have? How many friends do I have sharing this 2/3 of, just shout it out. Okay, so 4 friends are going to share 2/3 of a pizza. All right, so I need to split my pizza into 4 portions. And when I do that, this is just like a bar model, except it's round. I'm going to split the entire pie into different sized portions. All right, so I just cut each of those in half. Now, how many portions do I have on my pie? What's my whole? Like, what is my whole divided up into now? Shafiq? Is it directly related to this?
Yes.
Okay, go ahead. Well, I'm getting there. First of all, but I'm walking you through it.
Oh, no.
So I just drew some lines on my model, right? On my model right here. You're just a mess.
I know.
Things are just like flying off desks at me. All right. Okay, so Shafiq, I'm illustrating how I got to sixths. First of all, I split each of my portions into 2 portions, right? So each of the 4 friends could have some because I only had two portions for them to share. Is that very nice for 4 people? No, then only 2 people would get a portion. So I split it and I got 4 portions. And now you can see that each friend is going to get a portion, but I have now split up my bar model, which is a circle model, into a different denominator. What's my denominator for my whole now? Rejveer. Yeah, now I have sixths, right? So how many sixths does each kid get? Show me on your fingers, you guys. Each kid gets 1/6, right? Okay, so not super hard to visualize, is it? Okay, we just showed how we can divide up 2/3 into 4 portions by dividing the thirds actually into 6 by multiplying them into 2. So we got sixths. All right, so method 1 is to do this. Actually, we're just gonna jump right to copy.flip. So here's what we do. If I want to divide 2/3 by 4, we just did it visually. We're going to do something called copy.flip. Have you guys heard of that before?
Yeah.
Do you remember doing this in 5th grade?
Yeah.
The copy refers to the first fraction. So when you're reading the problem from left to right, we need to copy that first fraction. So that's where the 2/3 is coming from, okay? We're going to change division to multiplication. And we're going to flip the second number. If it's a whole number, we're going to flip it to a fraction. If it's a fraction, we're going to flip it just to its reciprocal. What's the reciprocal of 4? Uzziah? You just froze your brain?
2.
No, let's look at it. Uzziah, here's what a 4 looks like as a fraction.
Oh.
What's the reciprocal? It's 1/4. So my computer keeps doing the thing where it changes slides and I don't want it to change slides. Yeah, it's 1/4. Now all I have to do is multiply. It's pretty easy, isn't it, you guys? The reason we have such a long discussion about it is because I want you to understand conceptually what we're doing when we divide by fractions. All right, so your next slide is you're going to take notes on the process. So this is the copy.flip. So what you're going to do is you're going to leave the first fraction or whole number. You're going to replace the division sign with a multiplication sign. That's what the dot is. Okay, so in parentheses, go ahead and write dot. You're going to reciprocate or flip the second fraction. That's where the flip comes from. And then from that point on, you're just doing multiplication with fractions. You can use cancellation, you can cross cancel if you want to. And then you just multiply numerator times numerator and denominator times denominator, and then simplify if needed. Let's see if this always works. It does, or they wouldn't teach it to you as an algorithm, but let's just prove it, okay? Class, what's 12 divided by 2? Okay, now let's copy.flip. 12 times 1/2. What's 12 times 1/2? What's 24 divided by 3?
8, 7, 8, 8.
Okay, thank you, friends. All right, that's all right. That's all right. We need to practice math facts, I think. What is 24 times 1/3? Notice I'm flipping that. What is it? It's 8, right? Do you agree that the reciprocal of 2 is 1/2, class? Do you agree that the reciprocal of 3 is 1/3? Okay, what is 12 divided by 1/2? What is how many 1/2s can I get out of 12? 24. What's the reciprocal of 1/2? No, what's the reciprocal of 1/2? 2. So 12 times 2 is, what is 24 divided by 1/3? In other words, how many 1/3s can I get out of 24? I heard it. Spartan vote, is it 8 or 72? Visualize it. You guys know that's okay. I want you to visualize it. If you were to cut 24 cookies into thirds, you would have a whole lot of chunks of cookies, right? You have way more than 8 cookies, right? Yeah, it's 72. And then what, let's just prove this. 24 times, what's the reciprocal of 1/3? Morgan? 3. And 24 times 3 is 72. Okay, good. All right. Oh, I had one more thing. I'm sorry. The nickname for this process is copy.flip. Make sure you have that written down. Copy.flip. Okay. We all have this slide? Get it from neighbor if you need to. All right, let's do another one. Oh, this is the same problem. We already did this copy.flip way, so we're not going to do it again. Let's move on. Luke has 1/2 of a yard of rope. He cuts the rope into 5 equal pieces. What is the length of each piece? All right, the question that I'm asking is, if I divide this 1/2 yard rope into 5 pieces, what's the length of each piece? Am I going to end up with pieces that are bigger or smaller than 1/2 yard, you guys? Smaller. Imagine I've got 1/2 yard. I got to chunk it up into 5. They're going to be small. Cecilia, what would you do? Okay, I'm going to just, let me go backwards for just a second. You are absolutely right to do 1/2 times 1/5, but first I want to write the actual problem, which is 1/2 divided by 5. So yeah, 1/2 divided by 5, and we're actually going to bar model this. You guys do this with me, please. We've got 1/2 of a yard, right? Here's my 1/2. There's my full yard, there's my 1/2 yard. And I want to divide this up into 5 portions. And we want to know the length of each piece. And just because we did that on one side means we probably should do that on the other side. Okay, so what's the length of each piece? And Cecilia already told us how to do this. She said 1/2 divided by 5. When we copy.flip it, it's going to be 1/2 times 1/5. And my answer, Cecilia, 1/10 of a yard. Does that match up with our bar model, folks? Yeah, it does, right? Because we divided the half up into 5 pieces, but we went ahead and divided the whole up as well, because whatever we do to one side of the bar model, we're going to do to the whole part of the bar model. And now I've got tenths there instead of halves. Good. All right, let's do another one. 3/4 of the students in a class are girls. Let's start with a bar model. Let's start with a better bar model. This is Jurgens. Let's try this again. All right, so I'm going to start by dividing up into quarters. And we're going to label 3/4 girls. These students are separated into 9 groups. What fraction of the students is each group of girls? So we're saying that the group of girls is separated into 9 groups. So let's not do any math quite yet, you guys. Can I separate the girls' 3 units into 9 groups? And how would I do that? What would you do, Mira?
You pick 3 boxes of each
Yeah, I'm gonna subdivide each of those 3 units into 3, which means I'm also gonna subdivide that last unit into 3 as well. Okay, how many units now? We really wanna know what this portion of the whole is. What is that portion of the whole without doing math, you guys? Just look at the bar model. I started with fourths, I subdivided into each unit into 3. Now what do I have up there? Kylie?
1/12.
Yeah, exactly. I have 12ths now, right? So if we were to do this mathematically, we have 3/4 divided by 9, which is going to equal 3/4 times 1/9. So that's my copy dot flip. And then I can go ahead and cross cancel. And I have 1/12. 1/12 of the students, and I'm going to add a label of the students are in each group of girls. How are we doing so far, folks? I got a thermometer from like 4 of you. Okay, I need a little bit more of a sample size here. Sample size. Okay, good. So if your thumb is like pointing in the air, like to a corner in the room instead of at the ceiling, or it's pointing at one of the side walls, that's okay because we're gonna keep working on this. All right. What I want you to remember is what's our nickname for the process that we're learning today? What's our nickname, Kylie Biss? Copy dot flip, right? And I really want you to understand what we're doing conceptually, but you have some days to be able to get there, okay? So if you can't remember anything else, remember copy dot flip, remember how to do it. And then we're gonna keep working on like really understanding what it is that we're doing conceptually, okay? So that's all right. All right, let's keep going. Chelsea has 5 apple tarts. She cuts each tart into 1/2. Find the number of half tarts that Chelsea has. Don't even do the math, guys. Don't do the procedure. What do you think? Dorothy? She's got 5 apple tarts and she's going to cut each tart into half. How many half tarts does she have now? She has 10, right? Yeah, good. Each person's going to get a half a tart. You can feed 10 people. Let's go ahead and do this mathematically now. If we do this with copy dot flip, we're going to divide 5 tarts by 1/2. Our question is, how many half tarts can we get from 5 tarts? All right, that's the division question. 5 divided by 1/2. Let's copy dot flip that. Remember, copy the first number or fraction, change division to multiplication, flip the second fraction or number to its reciprocal. And I have 5 times 2. And does that match up with what Dorothy said and what you see in front of you? Yeah, she's got 10 half tarts. 10 half tarts. Here's how you would label that. Declan. Just ignore that. Do copy dot flip. Method 1, the way that they want you to do it is just to visualize it. So if we were visualizing 5 divided by 1/2, and you're already doing that. So what I really need for you to practice is method 2. Landon?
Was a great assignment, but could you just box 10 and write half out?
Half tarts. Yeah, so let me actually give you a better way to do that because I want you to have the label with the number. Let's do 10 and then let's just do like a colon, 10 half tarts, because it gets confusing when we're talking about half tarts. Is it 10 and a half tarts or is it 10 half tarts, right? So just use a colon or use something to make it clear to your grader that you're talking about a size of a half tart and there are 10 of them. Michael, you can do that. You could do 10 half tarts. I like that the best, I think. I like that better than my way. Okay. You guys have an exit ticket. We're just gonna use that as a Toyo right now. So let's go ahead and do that one right now. 3 cakes are shared equally among some children. How many kids win? The kids get 3/4 of a cake. This is like the cakewalk, maybe. Because not all the kids are gonna get a cake. Finish off my problem here. What am I dividing the 3 cakes by? Yes, nice job. All right, and then what's my next step? Okay, so 3/1 times what? Time, well, we're not doing, but see, here's the thing. We can't switch it, just like subtraction, we can't switch things around in division. Because we've got 3 cakes and we want to know how many kids can get 3/4 of a cake, right? So we're dividing, our question is how many 3/4 can we get out of those 3 cakes? We're gonna get 1, 2, 3, and we're gonna end up getting 1 more set of 3/4. It's gonna give us 4 sets of 3/4. But how do we get there mathematically is really what we need to figure out. So we're dividing 3 cakes up by 3/4. So copy.flip means I'm going to copy that first number. Don't do anything with the first number. I'm going to change division to multiplication, and I'm going to flip the second fraction. So 3/4 becomes what? 4/3. There you go. Now I can cross cancel. I've got some 3's here in my numerator and a denominator. And whoops, did it work out? I've got 1 times 4 and 1 times 1. Which technology, folks, I'm telling you, which gives me 4/1. So I've got 4, and Michael suggested that we write all of these out. 3/4 cake. Okay. So if you got, oh, you know what? I made a mistake. That is not our unit, because our question was how many children got 3/4 of a cake? How many children got 3/4 of a cake? It was 4. Yeah. So our unit actually is children, not 3/4. All right. You guys are going to do workbook exercise 5 tonight. Pages 54 through 56.